Okay, well, welcome all. And, I would like to welcome my old friend, Tom Burns. We used to work together 20 years, like 30 years, yeah. Yeah, since, back at Alias Wavefront.
I got the jacket.
Oh, good, okay, there we go. Yeah, for those in the audience who can't see, Tom is showing off his Alias jacket. I arrived too late in the company to get that. They distributed those the year before I showed up, so I never got the leather jacket, but Tom does. So Tom is now CTO in the Media and Entertainment division at Dell Computers, and I know him as being one of the key visionaries in terms of the future of VFX from way back when, and he still is today, but he's learned so much more. So today he's accepted to go and give us a presentation about where he sees updated trends in VFX. Take it away, Tom.
Thank you, Alan. Hi, everybody. Thank you for that wonderful intro. All that stuff means is that I'm old. But the reason I brought the Alias jacket is because that was the start of maybe not computer graphics as a whole, because companies like Omnibus and Eugene Fumet's research and other things predated Alias as computer-aided modeling and animation and rendering. But it is really worth noting how many interesting things came out of that 1982 startup. And it's rare that startups keep going. And here they have been, acquired by one company, taken private, acquired by another company, still going and still cranking out essentially 3D software creator tools, which is the part of the market that I love the best. Even though I'm not creative, what you're going to see is all technical. But I've been working with and supporting creatives my whole life. And so, as Alana says, I'm not necessarily a visionary. When I was at Alias, I was like the media guy, talking about optochemical technology and rust-coated plastic and things like that. Now, of course, everything is digital files on a shared storage device, whether that be a public cloud or something in your own machine room. And so we're going to get into the changes that everybody calls the cloud. I'm going to break down a little bit more deeply for you. So I'm a tech guy. Is that about the right? Oh no, here's my little wait, let me get my mouse happening here. So is this the rough agenda that I put together on the not Bright Talk, what's it called again? Event. Whoa. Anyway, on the site, I threw together some things, and you guys, this is just stuff that I think is cool. If people are not interested in that or want to go in a different direction, I am totally happy to talk about anything and everything. My personal history kind of blends broadcast, visual effects, and post-production. And that's one of the ways that I'm going to start talking about these trends. Yes?
Will there not be any touch on virtual production?
Absolutely. Virtual production is the hottest thing in the world right now. And when you see, I guess I changed that. Well, real-time rendering, the second point is what I mean is when I will address virtual production. But if anybody has any particular questions, or if you think what I'm saying is wrong, please sing out. I don't know how we're going to listen to the people on the phone, but maybe you could do something in the chat, because if I unmute, it's going to make I don't want to do that.
People should pose their questions in the chat.
So we'll keep a chat window open here, and please, if you have questions, or if you just want to say the presenter, then that's what that's for. I started out with the question, is cloud just another form of virtualization? So from a tech point of view, everybody, I assume, knows what cloud is. Does everybody understand virtualization, either with commercial hypervisors like VMware or more inexpensive ones from Microsoft and the open source community? The ability to run something not on a bare metal computer that only does one thing. So the reason I asked about does cloud just mean virtualization is because I had the good, and you know what, let me take a moment now and thank my employer, Dell Technologies, who, this is not a sales thing, I'm not talking about, in fact, I'm gonna talk about more non-Dell than Dell stuff. But I'm thankful to my employer for giving me the space and the time to think about interesting things and to be fine with me coming and talking in a non-commercial venue about what I think is cool, even if it's not sales related or Dell related. So thanks, Dell. But I was lucky enough to go to this tech retreat called the Hollywood Professional Alliance. And one of the architects who was on the original Movie Labs 2030 vision paper, any recognition as to Movie Labs? I'm gonna get into it at the end, but it's a studio think tank, and all the studios globally are represented there. And the one thing that he wished that he had said in one of the important principles of the Movie Labs 2030 vision paper is that he wished he'd called it virtualization instead of cloud, because cloud is just too vague a term. And so I'm going to get into that a bit. The first thing you have to do is separate cloud compute, which is super easy, from cloud storage, which is super difficult, only because you have to pay the freight, getting it up to the cloud and then getting it back down again. And that's the problem with cloud storage. What a lot of people are looking at is what they call a hybrid workflow, especially in geo-distributed VFX productions. And we're going to look at a few of those, where you have one single file-based, okay, forget it. I'm jumping ahead of myself. I'm going to talk about Movie Labs. I'm going to talk about object storage, and I'm going to talk about why file systems have reached not the end, but they've reached one particular evolutionary branch in their history. And object store, which is it's not a file system, right? It's an object store, and we're going to look into the difference of those two. But that's the only technology that can suit the scaling needs of a large tentpole picture. Project Ice Cream, the new the most recent Matrix feature from Warner Brothers, had 35. Any one of these 35 would be a big VFX company in its own right, capable of churning out their own intellectual property or working for hire on other people's pictures. 35 of these companies, plus the Warner Studio infrastructure and people, were what's required these days to produce a tentpole picture like the most recent Matrix. Resurrections, one of those. So that's really interesting in these days of geo-distributed collaborative VFX production, how a single file system is just not enough anymore, even if it's a scale-out file system that can scale to 80 petabytes in a single namespace. I'm going to talk about a single namespace and why that's important. But again, just checking in. This is all from my point of view, which is, the director of infrastructure level at a VFX shop thinking about, here's the question that when I was in the industry, the question I got asked the most. A sequence supervisor comes to me and says, I need 10,000 cores to render this sequence. It's really important. What can you give me? And as the director of infrastructure, I might have a choice between what you call rocks, pebbles, and sand, right? Rocks are the fully capitalized on-prem render nodes, whether it's GPUs or CPUs, and we're going to get into that as well. Rocks are the fully capitalized on-prem infrastructure that hopefully you're running at 99% efficiency, because that's a way of making sure you get the most value out of your on-prem render infrastructure. The pebbles are the project-based. They could be OpEx, they could be CapEx, but they're not going to hit your base load. You're not going to hit your base CapEx budget. They're project-based, which means I can park them in an Equinix Colo, or I can borrow some resources from CDW Studio Cloud, or I can move this to another part of the Warner infrastructure, wherever. It's project-based, I'm going to move it around. And sand is the pure burstable goodness that is the public cloud. It is just always there for the last 2 months of the production when you need to finish the project. And so really we have to separate what we think of as cloud. And for everything that we used to have at the edge, some people say cloud to ground, some people say cloud to edge, but we're talking about the place where the artists sit, right? Whether it's Maya, whether it's compositing, whether it's game development, whether it's video editing, audio editing, the place where the artists sit, actually, it could even be in an 18-wheeler, what they call an OB van, outside broadcast van for, things like that. That's an edge. All of these virtual production volumes, with their insane data production and data consumption, they're the hot edge. They're the most performant edge in these virtual production volumes because of the amount of data that has to go in to support the real-time rendering. So there's an awful lot of ways to look at this, but the most important thing is that we start to separate where's my storage from where's my compute. And in the old days, speaking of the old days, mixed up on Windows here. Let's try. Is that it? So this is like from 2005. Okay. And you notice that the most interesting thing is that they have a separate item for data and for video, because of course video in the old days was all carried on coax, either analog or digital. Whereas now data, just put a gray splodge in the middle of that whole thing. Data, with apologies to Mark Andreessen, data has eaten the world, right? We no longer care about running traditional IT services like telecom because everybody's on Slack or whatever, you know what I'm saying? But the idea is, if in, let's say 2000 to 2005, if you could build something like this in one building, then, and you had roughly, back then it was like 1,000 cores. Now it's pretty much 10,000 cores that you need to get into the business. But we're going to talk about how core counts and core densities. I mean, from the year 2000, when this was, I think this was from, 2000 I finished. So I got to core. So this was 2002 that we did this architecture. And you notice how I blocked out all the secret sauce in value add and pipeline. I'm not going to share with you guys my 22-year-old intellectual property secrets. But in 2002, we built this for a picture for Disney called The Wild, which got its ass kicked by Madagascar. But look at the difference in terms of what was traditional IT, business systems and telecom and things like that, that had custom networks, custom applications and custom servers. Some of those business programs would run on the equivalent of a mainframe. It's so funny that when we're doing timeshare in the cloud, and I'm like, okay, that's just like mainframe computing with a dumb terminal at the edge. But anyway, so this is the way it used to look. And now we get into this digital transformation where we don't care about analog signals anymore. I've got so much, information in my head about analog audio and bias frequencies and things like that is useless and will never, ever be needed unless I take a job, archiving old rust-coated plastic media, which I might do someday. I like the old stuff. But the idea is broadcast used to be one, and now it's just a network connection. It's a service mesh where you can tap in with an app to whatever internet stream that you can see. And so the Internet of Things, I was going to get into this because sensors and real-time data are becoming very, very important in production, especially virtual production, but we might not have time to get into that. But the idea is, instead of a single source of broadcast and everybody receives the same thing, then now what we have is a decentralized content fabric, so that knowing how your signals are routed determines your quality of experience, and as well, just-in-time rendering. We used to actually produce a broadcast graphic and composite it into a real-time broadcast stream, and then it was aired along with the rest of the program. Now, your set-top box, whether that be an Apple TV or an Amazon Fire 4K stick or whatever you've got, a Roku or whatever, it's capable of doing those graphics generations in real time. So everything is now decentralized in terms of content creation as well as content consumption. The digital transformation is matched on the back end. Digital we think of as consumers, but really what's happening on the back end Any IT folks, anybody know about three-tier architecture where you would provision the servers and you'd provision the storage and you'd provision the networking? That was the old way that everything got done, right? Then we went to converged and hyper-converged infrastructure where you had like one box that had the servers and the storage in it, and it had some networking. And so by combining a cluster of those boxes, you would get to converged infrastructure or hyper-converged infrastructure when everything is just this cluster of compute and storage and networking. Now we're getting into what's called disaggregated and composable infrastructure. This is very much edge. We haven't talked about the cloud. This is still data center hardware infrastructure stuff. And I'm going to get into composable infrastructure and that a little later on because it's super interesting when you have different workflows like when the artists are on shift, they're going to be using those GPIs for a secure remote graphics edge. But at night, or whenever nobody's using those GPUs, they can be completely turned over to another application, such as training an AI model for something like, upsizing or QoS or, finding defects in the picture. There's a huge amount of very, very specific AI features that are being used now to accelerate things that used to take, real time. To pay some poor intern, to just sit there and watch a program and make sure that they never missed a bad frame or an audio beat or whatever. That was a terrible job. I don't know how many of you have done QA. But to have an AI go through and look for defects and then just flag them and have a human operator check them after the AI has flagged, that's one of the nicest things we've ever done for interns in the world. When I say workflow orchestration, if I say things like shotgun, shot grid, does everybody know what I'm talking about? So again, when everything was in that one single stack, and all of the files and all of the compute fit into one single room. Your asset manager was an angry divorced person running around with a clipboard going, where's the freaking file? Now, we just can't, it's not all interactive like that. It has to be under control of, some people call it media asset management, some people call it VFX production systems. I'm borrowing an older term from enterprise IT and calling it workflow orchestration. And in fact, if you look way, way back to things that IBM was doing, too early as it turned out, the enterprise service bus was the first attempt to try and take business principles and enterprise IT principles and apply them to a creative pipeline. Have you ever noticed how VFX people call it pipeline and post people call it workflow? I don't know either, but I'll tell you one thing. One of the biggest trends that's happened in my life after working in VFX for 10 years and then post-production for 10 years, post has effectively eaten visual effects. There's nothing separate now that the post company does that can't be done by a number of creative individuals that are usually attached to either the production department, because we're going to talk about previs and tech viz and all these other things that are parallelizing the process of getting a feature or episodic project done. And so the ability to use all of these kind of enterprise type features to streamline the process of production. It's not that the movie gets made any faster. It's just that the artists have more iteration times. If you've worked in VFX production, then you'll know there's a thing called CVBs, could be betters. And what that means is there'll be a shot. It's okay. We don't really have time or budget to do anything. So we park it in the final, but we know that if we get another 5,000 cores in a half a day opening up, then we're going to try and work on that CVB. So it's not that the picture gets done any faster or any cheaper. It's that it allows for more artistic iterations, which makes the creatives happy and ultimately makes the audience happy as well. So we went from enterprise service bus, which was old and didn't work in M&E. A service-oriented architecture is what a lot of broadcasters are kind of stuck on. But right now, anybody who's implementing a monolithic media asset management package should really look at replacing that with a mesh of APIs. Amazon I get mad at some of the things that Amazon does, but by moving everything to microservices and making everything accessible in that API-driven workflow orchestration middleware layer, that's the best thing that ever happened. Because if you can script something and repeat it, then you get more efficient. And the business of VFX has always been more of an artisanal craft rather than an engineering discipline, right? And so, like it or not, the world of VFX production are trying to adopt some of the tools and techniques, certainly the infrastructure and workflow of the enterprise data center, because that's where you can start to either enable more creative iterations, or you can, well, you never make it cheaper. Nobody ever says, yeah, the movie's done, let's just release it. So these are the IT transformation, a bunch of deep things, but labor, I mean, Canada was always a great place for VFX because we had cheap power and cheap real estate. Well, not in Vancouver anymore, but it used to be. Montreal, I guess, is still cheap real estate. But the idea is your artists who were gig workers, like work for hire, 1099s, they call them in the US. They had to physically move someplace so that they could show up at the office every day. And now between talent scarcity, which is a very real thing, if any of you are going to be VFX artists, and pandemic issues, that's all blown out the window. And I don't know what your pandemic, if you're all students, then you had a different pandemic experience than I did. But the idea is that everybody mostly took their computer home and tried to work, and it sucked. And that's been most people's experience for the last 2-3 years. So again, we're taking enterprise ways to provide a secure remote graphics edge. And that's how the artists are now interacting with this global namespace and this vague chunk of compute that is divided into rocks, pebbles, and sand. So everything is decentralized, everything is disaggregated, and the API-driven communication from the previous slide is the way that all these bits try and work together in harmony. Yeah. Who cares? Multi-cloud is a thing. If anybody's not familiar with Teradici and the PCO, and the PCO over IP protocol, it's really cool. Teradici just got bought by Dell's largest competitor, HPE. So there, see, I'm not being all talking about one company. So multi-cloud and the unified control plane, we're gonna give that a miss. Unless anybody's really into designing global workflows, that's like the advanced class. And I threw it in there because the unified control plane, everything could be in the cloud, except you don't have a single way. Remember that rocks, pebbles, sand I said? You got one control panel for your on-prem infrastructure, one control panel from like Equinix or whoever your colo provider is for that control panel, and you've got the whole AWS thing, which keeps changing and adding, and I can never find anything when they issue a new release. But 3 different control panels is really hard to move. So the unified control panel, I will simply hold up as an example of stuff that people are working on. Nobody's got it yet. There's probably 12 or 15 companies all working in that space to try and be the one, because, you know, are people familiar with Shotgun and ShotGrid? Somebody said yes.
Yes.
So I actually worked with Don Parker. That picture that I mentioned, the wild, Don built. Don and Isaac and Remco. No, not Remco. Anyway, they built that actually working on a picture. And then they went ahead and commercialized it successfully and got bought by Autodesk. So I hope they made a bunch of money.
Oh, software, it looks like network protocol called ShotGrid. I've never heard of that.
No, it's just
Yes.
so, you know, let's say that you're a VFX. Oh, you do know. Okay, sorry. Yeah, they renamed Autodesk. I don't know what's going on with that. I'm gonna show you some software. So anyway, has anybody heard of MPAA, the Motion Picture Association of America? They used to control the security, and it was all based around physical security, cameras, swipe readers, everything. Now the MPAA has morphed or whatever into the TPN, and it's much more about digital security, because this is the problem. Amazon by itself has fantastic security, probably better than any company that I don't work there, so probably better than any company I know. And Azure has fantastic security. And when you're doing your own stuff on-prem, you do the security so that you can sleep at night. The problem is the gozendas and the gozadas. And that's the weak point in designing these global VFX oriented workflows, is you have to pay attention, more attention, because everybody does security slightly differently. And again, it speaks to the lack of a unified control plane. A unified security console is what I'm hoping that my company and others will work on. So we went from that, that stack circa 2003, 2005 to this description. And this isn't even a complicated picture. This is a 12-minute short that was done in real time to convince a whole bunch of Hollywood people that cloud production was real. Now, yes, cloud production is real, but you will notice that they had some on-premise storage as a plan B in case, if your network provider has a hiccup, then that's a problem. So you have to design these or these hybrid workflows where some sites are a spoke in the sense that they have some on-prem infrastructure, and some, no, I said that wrong. Some sites are the hub. The hub sites have the on-prem infrastructure, and the spoke sites just have a network connection. And your pipeline has to work across wherever the creative is, wherever the infrastructure is. Sometimes it's in a hub site, sometimes it's in a spoke site. But well, you all know about anyway, I'm not going to get into number of cameras, number of lenses, number of frame rates. I mean, just coming up with a color pipeline is hard enough. And now people are saying, oh, I need to manage my lens metadata as well. And I'm like, do I really? Anyway, where are we here? Y'all. Here's the problem with almost all creative technical projects. This diagram is the compute, that diagram is the storage. Notice how they don't match. They don't line up. You don't need the same amount of compute when you have the most storage at the beginning. You just need a tiny bit of storage, and you don't even need a really heavy duty compute at the beginning, because all you're doing is previous. So this is the fundamental problem why shops are turning to a parallelized because it used to be, I mentioned that I worked on a picture in 2002, okay? And it was, do you know the software development style that they call waterfall? This team does their thing, and then this team does their thing, and then this team does their thing. Now, what's happening in software development is we're going for a DevOps or an agile style of software development, which means that everybody's always working on a live build all the time. Every 2 weeks, there's the sprint finishes, and you always have a usable, sometimes it's all it does is run and say hello world, but you always have a usable version of the code. I would like to posit that modern VFX production resembles nothing so much as agile software development, because we are all working in parallel. There are all these creative sprints. Every 2 weeks, when the studio money people want to see what's going on, there's always a live version with temp audio and temp graphics and temp this and temp that, but you can see the story. I love those, Disney and ILM and Pixar, they do the best, those, I call them breakdown reels. I don't know what the real term is for them. But when you can see the story as it develops from storyboards and look dev and, the set people and the hair and makeup people and everybody, and things just keep increasing in quality until finally you run out of time and you have to deliver the picture. Isn't that the rule of creative endeavors? Is you never finish, you just run out of time. But the problem is for a technical person trying to match up my compute needs with my VFX needs, it means that you can't do it the same way we used to do it anymore. So what we have now, I mentioned the 3-tier infrastructure has given way to hyper-converged. The largest studios that have a tremendous amount of IT support can manage to run hyper-converged infrastructure. So it's like elastic compute. So, I'm a compositor today, and I go in and my job is, some script. It's actually an Ansible script governed by Terraform, if anybody's interested in that. But my job will spin up a desktop, and I'm running Newt today. And then tomorrow I'm in a meeting with all the look devs. So they spin up another desktop, much lighter weight desktop, less GPU usage. And I can do like just Photoshop or something to look at color keys or whatever that is. But that's the advantage to hyperconverged. We are not yet in the latest stage of this roadmap, which is disaggregated or composable. I keep forgetting the word. Disaggregated or composable infrastructure, but I'm going to show you some examples of what that might look like. The examples come from oil and gas and AI and other industries. But you know, media and entertainment is always taking the best of breed from other vertical sectors and using them as well. So that's kind of what we're doing on a technology side. CPU, I mean, is it a surprise to anybody that CPUs are getting faster and there's like astounding core density increases? I'll tell you, Intel stumbled. You know, they've been the king for many years, and I'm sorry that they stumbled, but they stumbled. And into the gap comes AMD with 96 cores on their high-end EPYC chipset. And it turns out that core density just covers a multitude of sins. You can do so much more because remember those 10,000 cores that I asked for when I'm looking for a sequence to render. All of a sudden, if I can do that in half a rack instead of 10,000 cores in 2002 when we did the Wild, that was 5 racks full of 1U nodes. 5 racks just to get 10,000 cores. Now with these 96 core AMD EPYC 2 chipsets, oh, I should have brought one. I actually got one. It's like $10,000 worth of silicon. I mean, the one that I have is a dud. That's why they gave it to me. But anyway, so NUMA is non-uniform memory access. Renderers have typically had problems with NUMA architecture. So renderers like to see, you know, a single core going as fast as possible, high clock speeds, as opposed to parallelism. Now that GPUs are kind of happening, that's changed. But Intel's doing these chiplets. I honestly don't know whether that's going to make as big of a dent as AMD did just by cranking 96 cores onto a single chip. I don't know if you care about memory. Have you heard about HBM versus DDR6? DDR5 is the current generation of RAM. It's really fast. It's really expensive. And it only works with PCIe 5 because it needs the full 128 lanes of a PCIe 5 motherboard. And that's how you get the throughput is just by, you know, it's wider, shall we say. On the other, the HBM, it takes a narrower type of pin density, but it stacks them in a way that you get really good memory speeds in a lower power and lower cost environment.
I've noticed HBM hasn't basically kind of fell off. I mean, for a while, it was.
It's actually an older technology. That's right.
Yeah, no, it was definitely on par with the 5. But then as time moved on, you saw vendors like NVIDIA and AMD just basically slowly saying, no, we're going to GDDR6.
Yeah.
You almost heard nothing about HBM2.
So probably my bet is that HBM2 is going to be used in consumer app boxes because it's lower power. All these things that we're talking about with DDR5 and DDR6 memory, insane GPUs. GPUs basically, you know, suck the local power station dry. Oh yeah, and they happen to output pixels as a result. But if the power consumption is insane, and like sustainability is a really real thing. If we have to worry about power consumption as another axis on the density versus compute power consumption is a real problem, especially if you're in like an older building, you know, downtown Montreal, like old Montreal, you know, they've got fabulous, cool warehouse buildings and stuff like that. But you put a bunch of 75 kilowatt racks of render and you've like wiped out the whole power subsystem for all of downtown Montreal. So again, this is why you want to put your compute someplace where they have the power and they have the networking, either a purpose-built machine room, data center, or a colo, and there's tons of colos. And the reason I keep talking about Montreal is because power in Montreal is still 12.5 cents a kilowatt hour. We haven't seen that in Ontario for years, and I don't think we will again. And when you're talking about 75 kilowatts per rack and 20 racks in a machine room, power consumption is a real thing, not just for sustainability and green issues, but for costs as well. So where are we now? Okay, I love GPUs, but they are expensive and hot, and they suck an insane amount of power. But remember, I came from Silicon Graphics 100 years ago, right? Alias there, that jacket SGI bought Alias. So back in the day, SGI had the geometry engine, and this was on a 1 MIP machine, 1 million instructions, not even flops, just MIPS. And it cost $500,000, and it was the size of, I don't know, like it was bigger than that. And that was how an awful lot of pictures got made, was on an SGI Iris 1400 workstation. Insane, but true. I'll show you if depending on how long we go, I'll show you an example of a picture. Is it did I tell you that I have the clip from Enter the Elgin? No, I have it right now. I'll show it to you. I brought it. Anyway, so those geometry engines were a way of doing a specific kind of math, what's called 3D forward differencing. And they did it in hardware. And it happens to be a calculation that's really, really useful when you're making a renderer, specifically a ray tracer, and you need to be able to calculate light vectors very, very quickly. So there was 4 geometry engines. They were about that big each on a card that was like this big, and it cost maybe $250,000. And that was the world's first 4-core GPU. That literally was the birth of the GPU industry, because all those hardware engineers from Silicon Graphics went to NVIDIA, and boy, have they ever been developing that concept since. So anything that can be looked at in a, I always call it a Bayer pattern, you know what I mean? Where you've got a grid of red, green, blue, green, red, green. Anything that can be broken down into an array of repeating values that happens to look like RGB, that's a really good candidate for running on a GPU instead of a CPU. Now, we've seen over the evolution of normal computing that general purpose software running on general purpose CPUs will always outlive custom hardware accelerators, because the hardware accelerators are good for X years, and then the CPUs catch up, or the software doesn't. GPUs are hard to, the only thing that's harder to program than a GPU is an FPGA. That stuff is like assembler, man. That's really hard to program. But for certain applications, and we'll see one of those in network cards in a bit, FPGAs are awesome. How are we doing for time here? I'm just babbling as usual. So I'm going to go quick.
Go on forever. This is awesome.
Okay, but people have like dinner and stuff like that. So, okay, all I'm going to say is that as we learn to move data in and out of GPUs, the normal way of going across the bus involves hitting the CPU for an interrupt. Every token is what they call it. They don't call it a packet, it's a token in bus land. And that has to hit the CPU, which is like stupid and lots of latency. So there's many techniques. NVIDIA has one called GPU Direct that allow, they're all basically a class of RDMA, remote direct memory access, I think. And so anything that you can do to get latency out of the system by not going through the CPU on my way to the GPU, but just going bang, that purple box is a PCIe switch, which you now get on a chip these days. And that's another big trend. Is this the end of Ethernet in the data center? Because Thunderbolt 3 and Thunderbolt 4 has 2 lanes of PCIe 4, which is awesome. It's like 40 gigabit networking in a consumer standard. I'm using Thunderbolt right here. So this is, you heard it here first. Thunderbolt 3 is how you're going to start connecting all of these very, very low latency, high bandwidth appliances, such as little AI boxes and custom video boxes and things, because, you're looking at 2 milliseconds of latency latencycycy as opposed to 9. So if you can suck 7 milliseconds out of every single transaction, things start to really go fast. And I love Ethernet, and Ethernet is fabulous for our whole world, but in the edge, in the hot edge, in the performant edge, I'm calling it here, man. Thunderbolt is going to be, yeah, whoopity. But look at that. There's the latency instead of the normal Ethernet, like, you know, that spiky yellow thing you can think of as the buffering icon in your world. Okay, the problem with all this heat, liquid cooling is a hassle. There, same thing, super hassle. I mentioned before that modern episodic and feature productions resemble nothing so much as agile software development. This little thing happens to come from a game development infrastructure, and a tool that is very commonly used in game development is called Perforce. And I'm not trying to make a plug for Perforce, but I want to show you continuous integration. You've heard that phrase in software development. Now what they're saying is, let's apply continuous integration or DevOps to the process of making video games. This is this kind of integration of real-time techniques with traditional techniques, and all in the dev. If I go back one slide, all in a completely data-oriented environment. So that's why I threw that slide in there. Was Perforce originally is like a build manager. Do you use Git or Plastic or any of that? So Perforce is just this, or old school check in, check out, right? Source code control management systems, right?
Andy just moved from Perforce to Git.
Yeah, we keep moving. So,
That is very interesting.
so while I was at Autodesk, we moved from Perforce to Git as well, and Elements. Yes, Git Elements.
But nobody's liking Plastic, eh? They're all going back to Git.
And now I'm working.
Because Plastic was going to be the
Now I'm
big challenge.
working with Bojack on Minecraft, and they're on Git Elements.
Well, very interesting and good for me to know. Thank you.
Why? Why? I don't know the rationale.
Well, the idea is, what we're doing is we're taking a tool that is commonly used by a particular guy in the software development team. We used to call him the build whip. I don't know what his normal job is, but he's the guy who has to resolve all the dependencies by running around with a clipboard and going, you know, where's that freaking stuff? And this is my joke for media asset management and build whips. But the idea is now you can have a single source of truth that is capable of producing a build almost in real time. And that's how we get to virtual production.
No, I'm asking why, and I'm looking at virtual production because it's Git, Perforce makes more sense than Git does for virtual production, especially pre-production.
I don't know.
I've been exposed.
I am not in the world of that anymore. I just talk to people who are in the world of that. And so that's very interesting that they're moving away. Has Perforce jacked their licensing or something?
No, to be honest, I think it's the ecosystem. It's not so much the efficiency, it's the issues, it's the integration, it's everything around that enables people to collaborate and to do PRs and to review PRs and leave comments on changes and the whole, it's the ecosystem around it, not so much the efficiency of LFS chunks. They suck. They're not. Yeah.
You won't make me cry. So.
Yeah, it's.
Literally, I'm like, I wondering what's the advantage of
Handles blocks way better than LFS. LFS is painful. LFS is, it was a.
I don't know if people on the phone can hear this discussion, but we'll try and summarize it after the fact. I don't know how much time people have, but I'm going to keep going. I'm going to show you some things from SIGGRAPH Nationals last year that I found fun. Parsec is a competitor to Teradici, and since Teradici got bought by HP, I have to be aware of the competitors. F-Track is a competitor to ShotGrid. They got bought by Iconic. No, it's the same parent company. I forget the names. Anyway, they got a bunch of things. OptiTrack, this is a year old and it's completely obsolete because of the rapidity of the advances in virtual production camera trackers. But I liked them the best of everybody that I saw at, although MOSIS is coming up now. Immersive cooling, I mentioned. These are like non-water-based substances. So you just dip an open computer in these non-water-based coolants, and it's non-toxic and it's great. It's a heck of a mess to set up, but it's the only way. Once above 350 watts of CMOS, you're going to melt plastic. So anything that is over 350 watts, which is very small. Well, anyway, compared to all the cards in your computer, that's not very much. So liquid cooling is in your future. I hate to say it, but it is. I've seen blown air computing systems, and they seem to work well, and they're a lot less hassle than liquid cooling. But they aren't. I haven't seen them like as anything other than a science project at this point. I might have missed it though. Maybe there's something else happening. I mentioned this one company just because I had them in the slide, but there's other companies that are doing this, and I'm going to get back into what it is. But it basically means instead of using Ethernet to interconnect all the elements in your data center, we're using switched PCIe 4. So that's 128 gigatokens. It's almost a terabit per second of bandwidth. It's awesome. Everybody knows Foundry, everybody loves Nuke, but the point is, Foundry has taken projects just like Don Parker did with Shotgun and made a company out of it. Foundry has taken well, it's the opposite actually, because they're releasing it into open source, but Foundry has taken two projects. One, Open Timeline IO, is still on their own aegis, although it's available in Git. Open Asset IO is the one that's under the Academy Software Foundation. The Academy meaning SMPTE, the Academy is AMPAS, correct. So AMPAS has this Academy Software Foundation, and they are now serving as the open source repo for Open Asset IO, whereas the other one is on Git. Oh, sorry, Open Asset is on Git, Open Timeline IO is with the Academy Software Foundation. But just go to the Foundry website and you'll see all of that stuff. And so the idea is, remember I was saying that there is no one universal control plane. This isn't here yet. This isn't it. It might not ever be it, but this is the right step because nobody's going to say, oh, a vendor like Dell is going to do everything for you and it's going to cost this much and let me have your monthly fee, please. Because, all software companies are going to a subscription model. But when people who know what they're doing, such as Foundry, place these tools in the open source community and everybody works on them for the common good, I have every expectation that Open Timeline and Open Asset are going to become that Uber MAM or that API-driven workflow orchestration layer, whatever. And I'm calling them out here because I'm thrilled that they put that into open source. Starting to think about virtual production. And what's interesting about virtual production is that we are now sampling rather than synthesize. Because we used to build geometry out of curves. And now, if you have, okay, Whoopi, you can see me. That's really old. It happens to be a clip that I can show without royalties. So look at this. Anybody remember the Microsoft Kinect? Remember the first generation of Kinect that came out? So the Kinect is now that. Intel has the RealSense. RealSense LiDAR is cooler than the regular RealSense because it's real LiDAR as opposed to infrared grid of dots, which was the Kinect technology. But this stuff is getting cheap. And if I don't have to pay the equivalent of an artisanal sculptor to craft geometry, if I can simply either through photogrammetry or through actual depth capture or all these cool techniques, if I can just sample geometry, boom, it's in a game engine, boom, it's available. And this is why, remember I said that post has kind of eaten visual effects? Well, I'm wondering whether gaming is now going to, visual effects ate post, now gaming is going to eat VFX because the ability to do, traditional VFX, like 20 years ago VFX, like I'm used to, but the ability to sample and get accurate geometry as opposed to have to synthesize or sculpt, is one of the biggest trends that's happening all over the industry. So you've all probably seen a million virtual production demos. I happen to be fortunate enough to be at Lux Machina before they got acquired by NEP. Lux Machina was one of the first companies doing this. They made a name for themselves on The Mandalorian. Now they have a services group. And basically, if you don't know what's going on, there's a camera tracker on that camera. And so you can see that it's doing real-time composites on that screen on the right. You can also see the frustum is changing what is being rendered by a game engine. In this case, it's Unreal. What's being rendered changes according to where the camera is going. So you're basically doing real-time, in-camera visual effects with game resolution. And oh my goodness, gaming resolution is pretty darn good these days, okay? So if it's, and the best thing about virtual production, there's a screen on top, right? So that's contributing to the lighting that falls on your talent. So if you want to repeat the shot, if you want to do 47,000 takes and have magic hour in the lighting for each one of those 47,000 takes, this is the only way you can do it. If you realize, if your art director realizes that that plant is wrong and needs to be moved or changed, then a person in the game engine can just move or change the assets right there. We reload the game engine and we redo the shot. Now, reloading the game engine, that thing that I just said as if it's easy, it's really an enormous amount of, how quickly can you move a petabyte of data? Literally. That's what it takes to make a change in Unreal, bake it into a thing that can be loaded into the disguise console and then generated on the LED panel and resynced up so that they're ready for the shot. Like, I don't know about you, I don't have a good Ethernet, good internet at home. I got 1 gig, I guess. And it would take me a week to move a petabyte. Well, 4 days to move a petabyte of data. And these guys need to do it when, you know, these virtual production stages go for $100,000 a day, right? So imagine when you tell the producer, don't worry, it'll only be 5 minutes before we're ready to get the next shot lined up. You can imagine that anything that can get that data shot into the GPUs that form the Unreal game engine, that will be as valuable as possible. And so that's kind of the stuff. Oh, I'm not going to talk about Omniverse just for a bit, but lower latency, higher throughput, only at the edge. That right there is why I've been focusing on those trends of lower latency and higher throughput, is because it's worth, you know, whatever 5 minutes divided into $1 million is, it's worth exactly that much. If I can increase pushing a new scene to my Unreal engine in order to load up the new sequence and get the director and the crew to reset and do another take. Literally, it's worth that much. So, how many people are familiar with Pixar's Universal Scene Description Format, USD? So do you know that NVIDIA has taken USD and turned it into this tool called Omniverse? I don't know that the take-up has been huge in the market. And yet it's really cool because it allows for that, for that parallelization of workflow. When Netflix first introduced the concept of binge viewing, it was really hard on the Post House because the Post House had to keep all 8 episodes of a season open and unlocked on their storage because they might decide to make a story change in episode 10. And so you had to go back to episode 2 and do some research and do some reshoots and insert the new sequences into episode 2 so that it would make sense in episode 10. So it's really hard on the Post House. Now, we get everybody working in parallel courtesy of Omniverse. And frankly, I've seen more Omniverse in mechanical, like manufacturing floors and stuff than I have in M&E, and I can't understand why it hasn't been taken up more. You're ex-Autodesk or current Autodesk?
X, but I'll say this, you know, I'm glad you brought it up because otherwise I would have brought it up. The thing, here's the interesting thing. What it looks to me is, because having actually spoken to a few production houses in the city, one of their biggest pet peeves has been like, when you give them the infrastructure, like you tell them, okay, here's a G40N 4X large, here, you go do your thing, they're like, no, my scene wouldn't fit in this, I have a 500 gigabyte scene, it just won't fit here. So what they're doing at NVIDIA is saying, okay, here's a DGX2, there's a terabyte of video RAM, 500 GPUs, and the thing is that they have obviously built really good tools, as you're describing, to allow real-time collaboration. The problem is they own your assets. Like once they go in, it's kind of in their metaverse, like it's the omniverse kind of, and it's like,
I didn't know that.
so try pulling that out. Now wherever you're working in there, it's a beautiful universe, but you're again tuning into their universe, their matrix.
Good to know,
do
because
your stuff.
that's a real problem with corporate people and research people and, art people all trying to work is copyright and who owns your data and who owns your metadata. So I don't have a solution for that one. But anyway, I think Omniverse is cool, but as I say, I've seen more customers in doing a digital twin. Okay, I'm not going to play this whole thing, but this is, somebody posted this on LinkedIn just today, and I thought I would throw it in here. You can go. I'm just, did I not hit that? Oh no, here it goes. And I've got the sound down. I'm amazed at the quality. Like this is so-called previs. Hello, this is as good as a lot of TV commercials that I've seen. Like, yes, you can see that it's computer graphics in some places, but it's not bad at all. And this guy put this together that was originally just to do previs to block out a shot, and then it's just like I'm in awe that you're able to do all of that in a synthetic environment. Anyway, you can go and Google the thing, downtown car chase in NVIDIA Omniverse. Okay. Oops, what am I doing here? There we go. And so again, whether it's yeah, forget it. I don't need to give Omniverse any more plugs. Oh, I wanted to mention FPGAs. Does everybody realize that every time a packet comes into your network card, your 1 gig card that you got in your computer or whatever, in order to process that packet, the network card itself has to ping the CPU, put an interrupt on the CPU, and that happens for every single packet. Now they have things like jumbo frame, which makes it less time, 1,000 packets before they send an interrupt. But still, networking is built for reliability and failover, not for low latency things. So people have been doing packet offload on NICs for a while. Now they're starting to include a fully programmed, and this slide is old. This is the ConnectX 5. This is actually old. I just grabbed this because I wanted to have an example, but now on the ConnectX 6 and NVIDIA bought Mellanox, and now they're calling it a DPU, a data processing unit, because the FPGA on a Mellanox ConnectX 6 can do everything from like the compute type operations to video type operations. And I'll show you that so NVIDIA bought Mellanox. They have as intellectual property this thing called the RiverMax SDK. And RiverMax allows the DPU on an NVIDIA card to speak this new video standard. Video used to be serial digital that came over a piece of coax. All the broadcasters in the world are trying to move to IP-based transmission. That's why we have OTT services that come over your internet, and nobody has a cable box from Rogers or anybody anymore. ST2110 is the name of the standard for video over IP networks. And this functionality, the RiverMax SDK running on the Mellanox DPU, this Flowcaster is actually a Toronto company. A guy named James Brooks running Drastic Technologies is the ones who make Flowcaster. And so it was his technology that was used as a demo in NVIDIA's booth last IBC, because it basically turns the NIC into a video card, right? If I'm using my network interface card for normal networking things. And I can also use it to take a window right out of Adobe Premiere and drive it to a separate monitor or something like that. Then you don't, a video card's only a few $100s, but being able to save on not needing a video card if all I want to do is take a window out of my Adobe Premiere application and shoot it over to another display that also speaks this IP video standard called ST2110. So that's cool. Okay. We already talked about old school 3-tier, and then you start to look at converged infrastructure. Well, if you took those same 3 bare metal servers and they have, that's a GPU and that's some storage and that's whatever, and that's a network card and things like that. And you said, okay, I've got all of these different assets, my resource pools, as they call it. And so what happens if I have a job that one day requires a server to be built up with some of that stuff, and then another job, I might have a server. Oh, I did too many clicks there. But the idea is I now have 3 like virtual servers, if you will, but they're bare metal performance because it's just GPUs and network cards and memory and CPUs. But they're all connected by the PCIe switching. And here's how, this is what I think is really cool, is that if you have a PCIe switch, did anybody ever work in post when you have a DIT cart? And we used to do like a Macintosh with a whole bunch of extra slots. This is the grown-up version of a DIT cart, because this thing can have 20 GPUs in it. Now, you probably wouldn't use it. Probably what you would do is have like 8 GPUs on each side plus 100 gig network card. And then that would be basically your IO and compute. And because remember I mentioned about RDMA, how you can talk from the network card directly to the GPU without having to go up to the CPU and back again. That's why this disaggregated composable infrastructure is making such waves at the hot edge. It's because of the low latency and incredibly high throughput. With PCIe 5 now, we're talking about doubling. Every generation doubles the number of gigatokens. So I think we're up to, well, 2 terabits, I guess. 2 terabits. Did I ever in my life think I would say those words? No. But that's the kind of thing. Oh, here's something cool. Now for something completely different. See that? Thunderbolt 3 or 4, my favorite. So this is a box. It's got 12 NVMe sticks in it. And if you buy them as 4 gig NVMe, then you got 48 terabytes in a little box, no bigger than my laptop here, a little thicker than my laptop. And in this particular box, it's called Iodine. You can look them up, IODYNE. They don't even put a file system on it. It's just raw LUNs. They are still working on whether they're going to do a shared storage system or whatever. But if I was a 4-person Mac-based video work group, I would buy this in a second, because like 12 terabytes is only like $4,000 US or something. Now, it's useless as it is. You got to put a file system on it. You got to manually manage the sharing of who's got the volume open and what. It's like one of those old school shared, what do they call them? The write locking sands, like Tiger Sand, where one volume was open for writing and all the rest of them could be for reading. It's kind of like that's a bit clunky, but it's 20. And if you buy the big spindles, and you got 48 terabytes of NVMe for $24,000 or something. It's insane. So there's that, which has no file system and no nothing. The brick here is a 1 petabyte shuttle drive. Now they say with compression, they can get to 8 petabytes, blah, blah. I just say 0 because it's all media and entertainment files. So they're previously compressed. There's no entropy left to wring out of those files. So, but having a 1 petabyte shuttle drive that will transfer at 10 gig NFS speeds, or if you plug it into like the base station thing, then it'll go at PCIe transfer speeds. And the idea is, if you got the two, like, you know, those Blackmagic studio drives where you swap SSDs, this is like the giant brother of those things where you're writing, you're almost filled up a petabyte. You make sure the second unit's all ready to go. Whoops, this one's filled up. So you pull that, it's writing to the other one, and then you move it over and you copy a petabyte again at PCIe speeds. And then by that time you come back and the other one's finished writing. So these kind of onset things that have nothing to do with Ethernet and have nothing to do with file systems and nothing to do with traditional VFX computing as we know it. These are now the real things that are happening. And I encourage you all to Google Movie Labs 2030 Vision, and you will get this paper, and you will see that principle 1 says, ingest each asset once and never move it. And so the biggest trend in global collaborative production is if I have a global namespace, which has to be an object store, there's no other technology that can scale to the way that we need it. Then yes, it's tempting to say, okay, I'm going to ingest every object, every asset. I'm going to ingest that once and never move it. Because do you guys know about object store? A file system is like, you got to know the path name, right? So think of a parking garage. You got to know the floor that you're on and the aisle that you're on and what stall you parked it in. So that's like, you know, /root/users/applications or whatever. But with object store, it's valet parking. You get a ticket and you don't care where your car is. As long as you keep that ticket, then your car will never move. So being able to ingest each asset and never move it is really, really attractive. And if I was building a greenfield production now, I would adhere to these principles. But the problem is it breaks every workflow known to man. And when you're the mill or ILM or DNEG or somebody, they've worked on these pipelines for years, and they're a thing of beauty, but they can't be changed very easily. And so throwing in a vision that breaks all known workflows, it takes a while for people to be able to add. But again, Ansible and Terraform is the way that you can federate across different global namespaces. There's a bunch of things happening with object-based storage, and I think that's let's forget that. Object is the only technology that you can use, and let's just leave it at that. And that is it for me. So thank you very much.